Hello, this is Domenico with Easynomics, and this is the second part to calculating PED along an inelastic demand curve. In this case, we're going to lower price. In that previous video, we used the example of insulin, specifically 1 vial of Humalog, insulin lispro, originally priced in 1999 at $21, and 20 years later, it was increased to $332. We also looked at some consumption data. 2018 estimated that type 1 diabetics, there were about 1.6 million of them in the United States. Of that number, 187,000 being children and adolescents. But in another study, it stated that I think in 2018 there was an estimated 1.3 million US adults with type 1 diabetes. So that previous video used that data, and we calculated PED as you would be expected to do on a potential paper 2, paper 3 for higher level students. We went over those calculations, we went over the total revenue calculations, and we applied a question where we would increase price by 120%. So that's in that previous video, and at the end of this video there'll be a link to that. This one's more focused on lowering price and calculating PED. So we're going to have, here we have our market for 1 vial of Humalog, insulin lispro. Again, in this video, we're looking at the calculating PED with a decrease in price. We have our downward sloping demand curve labeled D1 equal to our marginal benefit, the quantity the quantity demanded of 1 vial of insulin measured on the x-axis, the price on the y-axis. We're starting at point A with an initial price at P1 with quantity at Q1, the price being $332 with quantity at 1.3 million. And then as the firm lowers price, there'll be an increase in the quantity demand, or lowering price from $332 to $21. We see that increase in the quantity of consumption from 1.3 million to 1.6 million. All right, so let's go ahead and calculate PED as a result of that change in price. So we're going to remember that the PED formula is equal to the percent change in the quantity demanded over the percent change in price. And we want to remember that percent change is equal to the final value minus the initial value divided by the initial value multiplied by 100. So here we have our final quantity of 1.6 million. That's our initial quantity of 1.3 million. So we can make that calculation. And that would be 1.6. I'll put M for million minus 1.3 M for million divided by 1.3 M for million. That multiplied by 100. And that entire value would be divided by the change in the price, the final price being $21, the initial $332. So that would be final minus initial divided by the initial price times 100 in brackets. And that would work out to, in this case, 300,000 divided by the 1.3 million. And that would work out to 0.230769, if I can squeeze that in. And we'll come back to that in just a moment. And that's going to all be divided by negative 311, 21 minus 332, divided by 332. And that's going to work out to negative 0.9367, if I'm squeezing that in. And so we're going to multiply this by 100. So this is equal to 0.230769 times 100 for the quantity value. That's going to be divided by the negative 0.9367 times 100. And that works out to 23 point, round up to the second significant figure, 0.8% divided by negative 93.67%. And that works out to negative 0.246, but we're going to round up to the second significant figure, negative 0.25. So essentially, PED is equal to, if you look at the absolute value, 0.25. So PED, again, less than 1, it's inelastic. Okay? So that would be how you would calculate it. On a test, you would get perhaps a diagram with the quantity, the quantity data, the price data, or even a table. And in that table, the price and quantity data, and you'd be asked to calculate the percent change as a result of price changing from an initial price to the final price, and looking at the impact on quantity from the initial quantity to the final quantity. So this is how you would calculate that. Now, we can also look at total revenue. Here we see that PED is less than 1, so we would expect that it's inelastic. So as we lower price, total revenue, there's a positive relationship between the two. It should be falling. And let's check and see if that is the case. Okay, so some quick total revenue calculations. Again, PED is equal to 0.25 when we look at the absolute value. So let's look at total revenue, all right? The initial total revenue, which I'll call total revenue 1, is equal to P1 times Q1, price times quantity, which is equal to, we can label these areas A, B, C, the surface areas of areas A plus B, which should be equal to the price of $332 multiplied by 1.3 million. So the initial total revenue, 332 times 1.3 million. So that was $431 million, 600,000. Okay. Then we're going to look at the change in total revenue. Total revenue after the fallen price is equal to P2 times Q2, which is equal to areas B plus C, which is equal to the new price of $21 multiplied by the increase in the quantity of consumption, 1.6 million. And so that equals 21 times 1.6. So that is 33,600,000. So clearly, we can see that the total revenue fell from 431,600,000 to 33,600,000. Again, illustrating that when PED is less than 1, we expect a positive relationship between price and total revenue. So as price falls, in this case, total revenue will fall, which is exactly what we see here. So unfortunately, that would be a bad decision by the firm that's seeking to maximize revenue. And that's it. So there's two videos that go together to illustrate how we would calculate this. We're using an inelastic demand curve to illustrate calculations of PED and total revenue. If you have any questions, just feel free to comment those questions, and don't forget to subscribe and to like. Thank you so much.